Hello everyone. Welcome to this lesson about the stair calculation. That's the base skills for architectural technician, architectural technologists, interior designers, and the people are involved in the design for building. What today we are going over is to know how to calculate the number of steps from a level to another level with all this given information as the site measurement or based on the building assembly. And we want to find all these numbers and find a solution for how to do this project using AutoCAD. The floor to floor is 3764. There is going to be a door somewhere in here, and the going from the first floor to second floor is the matter of this exercise as we are moving forward to it. All right, so let's take a look at the numbers provided. Floor to floor is 3764. The stair width should be 1200. Maximum rise 180, and run is between 280 to 355. We are going to get some numbers to make this happen. What we are going to do as we show all the calculations and so on, let's use the calculator here. So in the calculator, we are going to put these numbers in place. 3764 divided by, we use the divide, by 180. That's the maximum rise we can go with. So we become 20.911 here. This is the 20.911. Rounded up to the next number. So the number of steps is going to be 21 steps. Means if we divide that 3764 divided by 21 steps, then each step is going to be 179.238, which is less than 180. So that number is acceptable by the building code, and we are going to create a drawing based on this number to show how many steps we can get from, how should we draw those steps from first floor to the second floor. We are trying to hold to 1200 for the landing since the width of the stairs is stayed at 1200. So let's bear with me to go to AutoCAD for a second. Okay, here is the AutoCAD, and I prepared something before to help you understand this concept better. What we are normally doing is basically drawing a line from end of this line to the other line, and I'm going to move it so you can see it. This is the line I just drew. This line has a length of, if you take a list from it, you will see the height of this is 3764. Let's take a look at it. Here it is 3764. So that's exactly the number we wanted. So this datum to that datum has been offset to exactly be 3764. Now what we are going to do, you're going to select this line and use the command divide. Let me just divide command. Divide command, and then you're going to select this line, and what you're going to do, you're going to say 21. So by this command, this piece of line will become 21 equal pieces. Bang. So here are a bunch of node is going to be from here and there, all going to explain one step as I drew it already. So let me just do a quick copy of what I have done before, so I can bring this just quickly forward to show you what I did. So here is, let me change the color for this guy. You would be able to see it a bit better. I'm going to change it to red. So here it is. This step starts from this divide to that divide, exactly to one piece of that 21, and it needs to have about 25.4 millimeters of nosing. 1 inch nosing in Canada is basically very common. Now what I would like to do is draw a line from this end up, and I'm going to offset this line 325. That's going to be this much. So this is a 1 foot and 1 inch. Before this was 1 foot, so I'm going to change that to the 1 foot and 1 inch. This is basically the number I wanted the rest of the stairs to be. I would erase the lines that I don't need anymore, and what I would like to do now, I'm going to move this a bit further out, maybe somewhere in here, just to give myself enough space, and then I would copy this to the end, and then I would like to copy this all the way to the top. So 1 step, 2 step, 3 steps, 4, 5, 6, 7, 8, 9, and then 10. Because this is 21 steps, if we go back to the PDF, I wrote down in here, one side of the stair will be 10 and the other side will be 11 steps. These can change to 9 and 12, but it depends on your situation in the floor plan. If they become as close as possible, it is better to have the landing somewhere in the range of middle. But since the number of steps is odd number, it is not possible to keep them exactly the same numbers. If it was basically 22, so we can add 11 and 11, but in this case, this is only 10 and 11, right? So based on that, we are going to do this in AutoCAD, the rest of the assignment. Just to make this look a little bit better, I would use the match property to make them look the similar colors. If you want, at this point, there are basically separate pieces. If you like to make them all one piece, because I drew them by polyline, then if you use the fillet command, that's going to be connect everything together as one piece. Hence, it's going to be easier for the operation. If I need to get 11 steps, then I would only select them once. And here I am. Now all of them become one piece. So if I copy this and then put it aside and then do the mirror, I'll remove the rest. I will move this up to be somewhere in that area. I'm going to move it to the top. Okay, so here it is. I need one more step. I'm going to copy this one more time from this end to this end, because I have 11 steps. I would trim the rest. So this one is going to be trim, and I can erase the rest. Now I have 21 steps. All is good. Looks really fine, and that's how I want it. I'm going to erase what I have from the past. This is not the case anymore. I'm going to copy this wall. So here is basically the 6 meter of what I have. Let's go back to the assignment. I think that was a different number. Let's take a look at this assignment. Yes, it's 5200. So let's make it 5200. If you want to make it 5200, this is basically the line, this green line stays at the face of the wall here. I'm going to basically show it like that. And I'm going to offset this 5200 and grab that and then toss it to this side. This is 5200. So what I would like to do now, I'm going to move this wall with that grid line from this to the face of this wall. Okay, so I'm going to erase the remaining that I don't need, and I'm going to use a half a block as this is a concrete block, it's a half a concrete block, and put it on that corner, and technically it should be rotated 90 degree. It's become exactly the same width. Put that end, and then I'm going to move this out 10 millimeters to, oops, 10 millimeters to provide a mortar joints, because these are mortar joints. What is really important is make sure all these white lines, they are in the depth point, because you don't want them to print. That's very, very tricky one. And you have to know that from the beginning. Okay, so what I would see here is the number 5200 did then count for the mortar joints. What I'm going to do, I'm going to move all these blocks to allow a little bit of a mortar joints. So move them all 10 millimeters. Now I have a little bit of a mortar joints, and this is going to be sit exactly where it needs to be seated. Let me move this. This is the job of the architectural technologists. They are going to come to an exact conclusion of the sizes. In this case, I have to have 10 millimeters of mortar joints. Then the numbers might change a bit, but don't worry, because you are the people to call for the real exact number in the end. So I'm going to put that back in here. Now I have exactly 10 millimeters of mortar joints. So this is basically, let's erase that. And now the distance between these two green lines, let me just use this dimension I already have to see how I can measure this. It should be a little bit more than 5200. Yeah, 5205. Yes, so the face-to-face of the wall is 5205 because of the size of all these blocks based on 390 and 190, which is the size of concrete block. All right, so this is basically the floor plan, and these are the lines, and I'm going to offset this grid line. Let's do the offset 1200, because we wanted to have a landing of 1200 coming to here. We are now ready. I'm going to get all those steps, put this end to that line, and this is going to be 1200. So this is 1200, and then I'm going to extend this all the way to the wall. So here is 1200. This is all the steps going up, and the door, which will be on this wall eventually. So that in this case, we are not going to have the door right in front. It has to basically rotate. Otherwise, as you see, this stair is not working. So you are responsible to verify all the sizes, making sure all the numbers are working, all the design is coming together in a way that is a best practice, constructible, and comply the building code. Otherwise, this drawing is not going to be usable for the contractors. Okay, so having said that, we now know this door has to be somewhere over there to basically go into the wall provided right here. I would basically argue that if I rotate this dynamic block, the best is mirror it and then rotate it, and then move it to where it needs to be. Normally it goes to the midpoint of the block, because behind the block has to be half a block. I'm going to erase this block, and then I'll bring this half a block that I made before, which is exactly half a block, and use it as a scale to put it in place. It has to be rotated. Okay, and then move from that corner to here, and then move it 10 for the sake of mortar. And then as you see, my door is exactly sitting where it needs to locate. These two other blocks should be removed, and then now here we have exactly the correct size for this door. It sits where it needs to be seated, and if I just take a distance from here to here, it's only 5 millimeters. It is possible to even this out. So what I would like to do, I'm going to move this door and then bring it to the midpoint of this small piece and erase that guy. Okay, so now both sides, they have a couple of millimeters extra. So now the door is sitting exactly where it needs to sit. I can get rid of this door now. Okay, steps going up this way. So the stairs should be designed at this point. How it's going to be, I'm going to move this and put it right at the nosing here. This nosing shows that in this corner, this door is going to be kick the step, which is no good. So I have to basically move it to bring it to a exact corner. And then making sure that the remaining, let me copy a concrete block and then rotate it to make sure that this is constructible based on the concrete block sizes. Going from this corner to here and then move it 10 millimeters for the sake of mortar joints. I'm going to remove this pillar. I don't need this pillar in this project because this is from the past, this project. Let me see how far we can push. I can push this back from here to there. And in this case, the step is not going to kick the door. Okay. All right. So let's basically do a mirror image of the wall right there, and then bring it to align this. With this existing wall. Okay, so let me move this, put it down because it has to be 10 millimeters. All of them, this needs to be 10 millimeters. I'm going to erase this and then copy this from this midpoint to this midpoint. So here is the wall, and then the rest has to be aligned with the exterior face of this concrete block wall. You see, these are like a Lego. I am playing with this with these graphics to make it constructible, to make it square, and making sure that what I am drawing right here is constructible. If it's not constructible, the working drawing is worthless. So we have to be very careful about what we are doing and measure it as many times as needed to make this drawing as accurate as you can. Otherwise, even a few millimeters here or there is going to be problematic. Okay, so now they should be fine by having all these numbers, and then removing the extras, and then bringing a half a block. I'm going to use this half a block I made before. To this corner, and then I'm going to allow 10 millimeters of the mortar joints. Oops. Now it should be fine. I would believe this is going to be again another 0.5 millimeters. Yeah, this is 5 millimeters. I'm going to do a quick line from here to there. I use the manufacturer's website to get the door sizes. That's why it's become like that. The doors and everything else is based on the real numbers taken from the manufacturers, and this is a dynamic block, as you see. All right, what I'm going to do, I'm going to remove these two lines. As you know, we did this landing for 1200. Let me just move it up and then use this dimension. See, this is 1200 now. That's exactly what we want. Then what I would like to do here is drawing another line. Let me just make it larger and then do another offset for 1200, which it is at this point. This is going to be 1200. And then I'm going to copy this line from any of these intersections, put it at the face of this wall, and then again another offset for 1200, grabbing this and then put it up. Your C-shape stairs or U-shape stairs is going to go up from this door and then comes back to here. Let's use these lines, copy them. So that is the nose, and here is the line below the nose. That would me allow to extend these two lines to here. I'm going to trim the line below and the line above, and I would change them to the layer stairs. I would change them to yellow just because I need them in a 0.2 thickness, and this line is going to be hidden. I'm going to use to hidden 2. In this case, these are all now ready to be moved forward, like from this nose to this nose. Go back up. Look at that. That's beautiful. Now this is the step number 2. Copy from this point forward. I would be able to use the multiple from here on and then adding all these steps. Perfect. Now it is basically steps coming here. If you count them as the nose is going up, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I am in the landing and the line go in underneath, which has to be matched with the hidden line. In here, it does match with the hidden line because the hidden line sits on them. Okay. We know if I copy this number and rotate it, we know for the fact the distance from wall to here is 1200, and if I copy this, since we offset the same, take it to this corner, so here is 1200. If I move them down there to not to be on my way, I can use them later. That's how it should be. Okay, we all know stairs is going to be, let me borrow this cut line, bring it down. I would like to make a comment right here. Okay, normally if we cut a stair or any floor plan, we cut that almost 1200 above the finished floor or 4 foot above the finished floor. Let's see, this red line, I'm going to offset that 1200, which is equal to 4 foot, and bang, I'm going to move this cut line to be at that 4 foot. No one does that technically in the realm of the drafting, but I would like to basically reconfirm the concept for everyone. If I move the previous object from this line to that line, it's now exact 1200, okay? So we cut the stairs in a step 1, 2, 3, 4, 5, 6. Somehow getting closer to 7. So you come up here and you will count 1, 2, 3, 4, 5, 6, almost 7. We are going to basically from that midpoint, from 1200 in basically I need this, or I can click on the and say 45 degree. So here is the 45 degree line. Extend the line to the corner of the wall. Okay, offset 50. Normally in Imperial I do a 2 inches. Now let me clean this trunk. This 2 is gone. Oops. Going between, everything in between is going to be removed. I'm going to remove this one. So here we go. Let me just do another little trim. We cut the stair, and then everything from this point forward in the right side of the picture has to be hidden line. So everything from here has to be hidden line. After cut, we go to hidden line. Okay. So MA, everything after this is going to be hidden line. The rest is easy. We are going to do the mirror and then take the midpoint of this. This has to be exact the size. So let me just bring this down. Now this line become exactly the width of the stairwell. And we do a mirror for this from the midpoint. As exactly sits over there. Check this line. So end of this means the hidden line for this line and the hidden line for that step should be in the same extent. So the nosing falls a little bit toward the right. Let's go back up and then fix that. What I would like to do now to move this and take it to where it needs to be. The rest of that is going to be a copy, and that copy may happen technically from this nose to this nose. If we go back up, now all the sizes are correct. I'm going to use the copy command and then nose to nose to nose. AutoCAD is a really nice tool and it has lots of capacity, super accurate, but you have to have a good understanding of the geometry for the building. If you know that, that's going to be much easier to navigate through. I made a few extra steps, which is okay. Well, we can fix those. See where the final line is falling. Let me copy this from that corner and the last step should fall in here. Let's go up. That's that line. It goes all the way. So here is going to be the last step. I had only one extra, it's not bad. Let me measure the remaining of this, copy to measure from the nosing to this corner. The landing in this case has become 1040. To be honest with you, I don't like this number. The reason I'm saying is because it's less than the width of my stairs, which is 1200, and that's not common. So normally the depth of the landing should be equal to size of the stair width. So in this case, I am 150 short. What I would like to do is, let's move everything. Let's move all the steps and so on. Let's move everything. At least one complete block. One complete block. So here is a one complete block, and then I'm going to add that. So this problem was not a good problem. Whoever designed it, it was not a good problem. You have to basically design a problem that it's constructible. If it's not constructible, no one likes it. Okay, and then copy. From this end all the way to that end. Now it is much better. The size is going to be more reasonable, and hopefully get to the nose. Now it's much better. So let's see what would be the best size. We can provide a feedback to the design team and saying the numbers you provided was not enough, and here is 5600 is minimum for this assignment. So when we go back to PDF, 5200 is not working. We need to change that to 5600, which I'm going to do that later on, because this is a picture and changing that is not as easy. Okay, let's stop for now. This is almost half an hour, and we'll see you later. So as we looked into the sizes, 5200 is not working. So we added 400 in here. And as you look into this assignment, I changed the number to 5600. When we go back to this picture, 0.5 is not much. I mean, 5 millimeters, it's nothing, but the real size is this what you see. So based on drafting convention, we are establishing the numbers, and all those numbers are working based on the real construction. So what I'm going to do is now I'm going to move these stairs away and this line away to be in the face of this wall. And as you see, now the landing is 1200. Let me just grab that. The landing is 1200 because this is going to sit in there. I'm going to grab that. If it's not working, I'm going to create a new dimension. That's not a big deal. Starting from this corner to the wall, and then here I am. I'll pull it up, match property to change the layer to where they are. There's this guy. Okay, so copy the number from here to here and grabbing that end from this corner to the nose and this is the number coming out. Erase the extras because we don't need them. However, I need to have let's move everything. To be away from the base. Now it is much better. Erasing the construction lines. I'm not going to use them again. That's the plan. Here is the stairs. Here's where they're falling. And I am hoping to get another correct number to this corner. Grab that end. Put the node where it's belonged to, and here is basically it. So these are the numbers. I'm coming to almost the answer for this assignment. Let me copy this, rotate it, and then move it. To the end. And then copy from this end to this end, and then change to the level. Okay. Okay, so almost the numbers we need for this assignment. Take a look. What numbers this assignment was asking? Let's close that. The numbers in this assignment is asking is 5600 is given now. I changed it. The height, it's now correct. All is good. A, B, and D is given now. We found it in this drawing. Take a look. See how beautiful those numbers are. 1200, 2975, and here is 1430. For the last landing, which is going to be larger as what it is. Let me see. So it is basically how we are dealing with this situation. Let me copy this number. Why this number is it's 10 differences. Oh, okay, because I'm showing to the grid line. This is showing to the grid line, and 10 is because of the mortar joints is away from the mortar joints. Both are correct. I mean, 10 millimeters is okay, but I was wondering why these 10 millimeters are different. Here is the nose to the wall, but here is a nose to the grid line. The rest is fine. All these numbers, as you see, are working, and we fulfill the need of this assignment. This is how I normally work. I mean, we have to find the numbers based on the drafting convention. And this drafting convention, AutoCAD provides me with a really good accuracy, and this accuracy is very important when we are drawing materials. They should be exactly the same size as they must be. Okay, so what I would like to do now, just to give it a better understanding, if I go to this intersection, grab that, and then put it to the face of the wall, and then move this back 10 millimeters. Now this is where exactly the numbers should be, because that was the convention from the beginning in the assignment, as we've been working on the working drawings 3, so the students are aware of what we've been doing. 10 is the offset, so 200, when we do the offset of 200, that has to fit on the exterior face of the concrete block wall, which is exactly fall in where it needs to be, because the concrete block wall is 190, it's not 200. That's the beauty of it. All right, so this is basically a quick way of looking into this assignment and how the parameters here is fulfill the question provided in this assignment. Okay, so hopefully you learned something. I know this shouldn't be this long, but apparently it takes time, and I would love you to ask me if any questions you have. Send me an email and I would be more than happy to help you. But the whole point of working drawing is putting every component of a building exactly as per a specification and the physical sizes, and all those dimensions has to go together based on the construction system, materials and methods, and then all these numbers are coming from those real size of the material. So this staircase is constructible because everything is based on the standards. Okay, hope you learned something. I'm gonna save it for the later, and that's it for today. Thank you very much. Enjoy the rest of your day, and talk to you guys later. Bye for now.